concentration of a solution can be represented as normality, molality, gram per liter, mole fraction, ppm parts per million, ppb parts per billion. All these are methods to tell you how much solute is present in a given volume or quantity of solution, right? So let us discuss some points over here. As in, if you want to represent normality, what is the formula for normality? Normality is gram equivalence of solute upon volume of solution in liters. All right. If volume of solution in liters is not given, volume is given in ml, what we are going to do? We will divide volume of given in ml by 1000 to convert it in liters. So the formula remains same, gram equivalence upon volume of solution in liters. If volume is given in ml, divide volume in ml up by 1000 to convert it into liters. So that is what has been given over here. Then you get a relation for the calculation of, let's say a question is asked, for complete neutralization of so and so much amount of acid, how much amount of base will be needed? Then that means neutralization applies over here. And what is the formula for that? The formula for neutralization is N1V1 equals to N2V2. Alright, N1V1 equals to N2V2 is the formula for neutralization. And what is normality? Normality we have discussed just now, that normality is gram equivalence upon volume of solution in liters. If normality is already given, then you need not calculate. If it is not given, you have to calculate. Sometimes what the examiner does is he gives molarity instead of normality. So you can convert molarity into normality by using a formula. Normality is equals to molarity into valency factor, or we sometimes we call this as n factor. So through this formula you can convert molarity into normality and then use this normality in this formula, right? So this could be for acid and the other thing will be for base. Use units same. If you're taking V1 in ml, use V2 in ml. If you're taking V1 in liters, use V2 in liters. So most of the times volume will be given in ml. So put volume in ml over here and put volume in ml over here. You need not do any sort of conversion. Alright. Next, what is valency factor or n factor? For acids, valency factor equals to basicity. For base, valency factor equals to acidity. So what is basicity of an acid? The number of ionizable H plus is called basicity of acid, right? So number of ionizable H plus depends on which acid you are talking about. If I am asking you to tell me basicity of HCl, you will say 1. Basicity of HNO3, you will say 1. Basicity of H2SO4, you will say 2. If I ask you basicity of H3PO4, the answer will be 3. So there are 3 oxy acids of phosphorus, H3PO2, H3PO3, H3PO4. So basicity of H3PO2 is 1, H3PO3 is 2 and H3PO4 is 3. That depends on number of OH groups present in that particular acid. In phosphoric acid H3PO4, there are 3 OH groups. So basicity is 3. In H3PO3, number of OH groups is 2. So basicity is 2. In H3PO2, number of OH group is 1. So basicity is 1. Alright, that is how we know basicity. Next, if somebody is asking you acidity of a base, you check out how many OH minus ions are given per molecule. As in NaOH, you will take acidity as 1. In calcium hydroxide, CaOH whole twice, acidity is 2 because 2 OH minus will be given by 1 molecule of calcium hydroxide. So this is it, acidity and basicity. And we have talked about this relation between normality and molarity already, that normality goes to molarity into valency factor or n factor. And that is over here mentioned what is n factor or valency factor, basicity or acidity. Mole fraction. Mole fraction is simple. What is mole fraction? There will be components, let's say A and B are dissolved in a solution. Then mole fraction of A will be moles of A upon moles of A plus moles of B. And similarly, mole fraction of B equals to moles of B upon total moles. Mole fraction is represented by X. If you're talking about moles of A, you will write XA. If you are talking about moles fraction of B, you will write XB. Alright. So this is all about mole fraction. And how you are going to calculate moles? How you are going to calculate moles is weight of substance upon molecular weight. Weight of substance upon molecular weight. That is the common formula used for moles. Other formulas for volume are volume of substance of a gas upon 22.4 liters, or number of entities of a substance upon Avogadro's number, that is 6.022 into 10 to the power 23, gives you number of moles. So there are three formulas for moles: weight by molar mass, number by Avogadro number, volume by 22.4 liter for a gas, right? And the last thing is parts per million. So parts per million, how you are going to calculate is mass of solute upon mass of solution into 10 to the power 6. Alright, so this is it for now.